Let's take a look at this handout. You can get this in the modules in Canvas. So it's a handout just on doing a little more work with function notation with 3 different types of functions. Okay, so I'd like to go ahead and go through these. Let's start with just f of x equals 3x minus 1. So we're given the rule and we're asked some questions about it. Okay, so let me go ahead and work through these with you. If you have a printer, it would help if you would print this and then you could fill it in as we go. If not, just do it on paper. All right, so if I wanted f of 3, then f of 3 could be found by just plugging in a 3 for x and working that out. 9 minus 1 would be 8, and my answer would be 8. For f of negative 2, same idea. I would do 3 times my input and then subtract 1. So negative 6 minus 1 would be negative 7. Calculators are okay, so if you struggle with operations with integers and that type of thing, you can just enter these expressions. Like I could enter that in a calculator and hit enter, and it would tell me negative 7. F of a feels like a trick question. Okay, the input is now an a. The function rule was 3 times my input minus 1. So that would be 3a minus 1. And that's all I can do. Those aren't like terms. There's nothing more I can do. All right. Now, I want you to look at these next two. And don't forget, the function we're dealing with, I'm going to write it again right here where you can see it, is 3 times your input minus 1. It'd be nice, really, if the rule were written without an x. It would make it, I think, less likely for you to misunderstand what it's saying. If you're asked, if you notice the difference between these two, do you notice how on f of x plus 1, do you notice how this is your input? Okay, where on the next one, the parenthesis closes after the x. So watch the difference between these two. So if I want f of the quantity x plus 1, think about it like this. That x plus 1 is all going in here at the top, right? So f of x plus 1 would equal 3 times your input, which is x plus 1, and then subtract 1. All right, now what you should do is a little simplifying. So I'm going to distribute the 3. And then 3 minus 1 I can work out and get 2. But I don't get a number this time. I get a new rule, okay? Similar to what happened on an input of a. I didn't get a number. I got a new formula. All right, now, you need to understand the difference between f of the quantity x plus 1 and f of x, where I close the parenthesis and then add 2. What's happening here is x is going in at the start. Then f acts on it and the output comes out, and then after it comes out, I add 2. Okay? So f of x plus 2, that would equal 3 times x minus 1. That's the output. And then after it comes out, I add 2. Like f of x is the 3x minus 1, and then I need to add 2. So it's just like throwing that plus 2 there at the end. Notice that's not the case on the previous problem. X plus 1, that's all part of your input. That's all going in at the top. Please work hard to make sense of this. What I have to do in sections 2.6 and 2.7 are really hard to explain, 2.6 I should say, hard to explain unless that makes sense, unless you can read the function notation and understand what it's trying to tell you to do. All right, so on this one, the 3x could just be written like that, and then negative 1 plus 2 would be plus 1. My final answer would be 3x plus 1. All right, now, if you knew how to do f of x plus 1, f of x plus h is just like it. So I'm inputting x plus h. So when I do that one, f of x plus h, isn't that going to equal 3 times my input minus 1? Right? Is that what that one was? Yeah. 3 times my input minus 1. So I'm going to distribute the 3, getting 3x plus 3h, but then none of those are like terms. That's really as good as it gets. Okay? Now you may need more room for this last box than what I actually gave you. So if you look at this, there's not one thing I'm going to plug into the rule for the function to get my answer. I've got to replace f of x plus h with what it's equal to. Let me see if I can get it to stay where I want it. F of x plus h is going to be replaced. I can't draw on it there, but so I'm going to replace that. Okay. Shoot. Okay. So I'm going to replace the f of x plus h. That gets replaced with 3x plus 3h minus 1, right? So this part right here, that's the f. When I do it in a table, that's what happens, and it's frustrating. So I get 3x plus 3h minus 1. Okay, that's the f of x plus h. Now, f of x, that's the original rule we had earlier. So isn't f of x 3 times x minus 1? And then this says subtract those two things. Okay. Wish I hadn't done it in a table. That's why it jumps like that. Okay. All right, now the denominator doesn't say f of h, it just says h. So I'm just going to divide that by h. All right, so the tricky part here is that there's a minus sign in between. So that's like a -1 that has to get distributed. So we have 3x plus 3h minus 1 minus 3x plus 1, because that -1 times the -1 would be positive. So notice the 3x and the -3x would add up to be 0. They'd cancel out. So would the -1 and the 1. So you'd have 3h over h, and the h is a common factor on top and bottom that you can cancel out. So your final answer turns out to be 3. Just 3. So this right here, it's almost like a formula that you're plugging into. Okay. All right, let's try one more of these. Let's go ahead and do the last one, and then I'll save this one to do with you in class. I'll save the middle one for later. So let's do this one at the end. Okay, trying to do the same thing but with the rule here. Okay. All right, so f of 3. Well, f of 3 would equal 1 over 3 minus 3. And, in this case, 1 divided by 0, that would be undefined. So I don't get anything matched up with it. When I do f of -2, I'd get 1 over -2 minus 3. That fraction bar is over on top of both of those. That would be 1 over -5. Let me write it here. And that would turn out to be a -1/5. Okay, now just a comment about negatives. -1 over 5, -1 on top over +5, or 1 over -5 are all the same. One negative somewhere. Okay? All right, now if I wanted f of a, that would be 1 over a minus 3. Period. I can't do any more. That fraction bar should be a little longer. If I wanted f of x plus 1, the function was 1 over my input minus 3. I can simplify the 1 minus 3, get 1 over x minus 2, but then that's as far as I can go. So that would be my answer to that one. Okay. All right, now, if I do f of x and then add 2, f of x, close that parenthesis and add 2, Then my input to the function is just x, so that's 1 over x minus 3, and then I add 2 after the fact. Now, sometimes this is not considered fully simplified, or technically it's not, because you could combine that into one term. To do that, you would have to get a common denominator. X minus 3 would be the common denominator. Oops. So what you would need is to multiply both the top and the bottom by x minus 3. Okay. And then you'd work on simplifying that. So you'd get 1 plus, let me go ahead and distribute the 2x minus 3. 2 times x, 2 times the 3 would be 6. That would be over the x minus 3. And then I'd need to simplify that a little bit more, the 1 and the negative 6. So I would get a 2x minus 5 over x minus 3. That's what's sometimes time-consuming on these rational functions, is to get the final answer. You sometimes have a lot of simplifying to do. Okay. All right, let's look at f of x plus h. F of x plus h. That's all my input. The function says to do 1 over your input and subtract 3, right? 1 over your input, see how those inputs match, and then subtract 3 from that input. Okay? And then that can't really be simplified, so that would be your final answer on that one. Now this one takes a little work to simplify. Okay? Remember this, to think of this right here as a formula that you're actually plugging into. So in this first spot, I'm going to put f of x plus h. Here, I'm going to put f of x, and then all of that's going to get divided by h. So 1 over x plus h minus 3 minus 1 over x minus 3, all divided by h. Now there's some simplifying we need to do here. Okay? There's lots of ways you can simplify. Okay? I'm going to write that a little smaller so I have some room there at the end to do my simplifying part. Okay? So I'm going to put my f of x plus h minus my f of x all over my h. So that's 1 over x plus h minus 3, then 1 over x minus 3 all divided by h. Okay, so I'm going to multiply here by the least common denominator. So I'm going to go ahead and take the least common multiple of these. So you do this if you took Math 100, you learn about least common multiples. This is a good way to simplify these. If I have a fraction, okay, I can multiply the top. Oops, I didn't write it correctly. I can multiply the top and the bottom by that least common multiple, which is this. It would actually get distributed to both, so I'm going to go ahead and write it over here also so I can see it. And I would have to multiply the top and the bottom by that least common multiple. All right, now what that helps me do, this expression that I had originally here is a complex fraction, little fractions inside of bigger ones. So by multiplying by the least common denominator of those two fractions, it knocks out those little denominators. And what I'm left with is an x minus 3. Then over here, I have an x plus h minus 3, but there's a minus sign in between, so make sure you're thinking about that. And then that's going to be divided by h, and then x plus h minus 3 times x minus 3. Okay. Now this is going to take a little bit more to simplify. Okay. So what I need to do is think about getting rid of the parentheses by distributing. Okay, and then combining like terms and seeing what happens at that point. Okay, so I'm going to try, this is always a little bit of a pain, but let me see if I can get another page on here. Okay. Let me just do it. Let me just do it on a new page down here. Okay. Sorry about this. Okay. There we go. So there we are. I'm just going to do it on a new page to finish it up. So what I'm going to do now is finish simplifying this. Okay. So the x minus 3. Let me see if for some reason it's kind of frozen. Okay. So I'm going to take my x minus 3. Give it a minute. Okay, let's see if it'll do it now. Okay, take the x minus 3, then distribute that -1, so that'd be negative x, negative h, but then plus 3. The denominator would have the h and these other two factors still. Don't multiply out the denominator. You won't want to do that down the road. Then x minus x would cancel out. Negative 3 plus 3 would cancel out. And I'd have a negative h on top. And then I'd have an h, an x plus h minus 3, and then an x minus 3. Okay. Now that negative h on the top is like a -1 times h. So next we can cancel the h's. We have a -1 over x plus h minus 3 times x minus 3, with that fraction bar over the top of both of those. That would be as far as you would go in pre-calculus. We'll talk more about this when we get back together. In calculus, I'll show you what you do at that point. But you need to be able to get to that point. This is going to wind up not being just a random expression. This right here is going to be called the difference quotient. And you're going to be expected to simplify, be able to find and simplify the difference quotient. Okay? I'm going to leave the one in the middle for us to do when we get back together.